Okay. Just to introduce for a moment, Niels is joining us again. So thank you again for speaking on another security topic in .NET, and this one in particular, I think, is very timely. I know in the news over the last week with the Log4j and all the kinds of potential issues that could happen with that, with code that's all over the place. And so supply chain, anywhere in your supply chain for your applications, if there are problems, security issues and so forth, that can make a huge impact, as we
Yeah,
were saying. And so
sure.
again, very timely. So Niels, I'll turn it over to you. Thanks again for joining.
Yeah, so thanks, Robert. Yeah, I think the last time I spoke, I said like, hey, next time it needs to be in person, but here we are again. And unfortunately, this is the only way for me also. I haven't been in the US since March of 2020, right? So that's the thing. But it doesn't matter, we can still do this. So we're going to talk about, as Robert mentioned, about the .NET software supply chain and about how we can secure it. I've been talking about this topic for 2 years, I think almost 1.5 years at least. I had a couple of initial talks on this, and there is some good movements. And as we have all seen in the news this week, a lot of stuff we can talk about. So it's going to be, I'm going to squeeze it in a bit, but it should be 45 minutes to an hour. So let's get started. First, briefly introduce myself with a big picture. That always scares me, but I'm Niels Tanis, and I work as a security researcher for Veracode, right? So we're based in Burlington, Mass. And I'm probably not from the US, as you have noticed. So I'm based in the Netherlands right now. It's 11 p.m. I'm keeping my voice down a bit. Hopefully the kids won't come out of bed and bump into my office. I told them that I was doing this, so let's hope for the best. I'm a security researcher at Veracode, but I've got a background in .NET development. I've done security consultancy, application security consultancy, also done some pen testing, ethical hacking, and then in 2015 I joined Veracode. I thought like, hey, building software is a lot more important than breaking. Breaking is nice, solving puzzles, it's good, but I think we should focus on building the right things. And I'm mostly working on our static analysis for .NET, right? So that's my part of the team. If you want to talk more about Veracode, drop me a message, because today, of course, we're going to talk about securing the .NET application software supply chain. I think if we look at the way that we started out, or as I started out my development career, stuff has evolved in such a way that the software that I wrote in the early 2000s is definitely different than the things that we produce nowadays, right? I started out with the first .NET bits, and once I was doing some work as a contractor for a company, then I would just like hand over an MSI to the IT department, say like, hey, install this on your machine, make sure that everybody has access to it, then you're good to go, which is of course a completely different world if we look at the way that we do software nowadays, with continuous delivery, with everything is automated, releases might be done in a matter of minutes, really quick, relatively quick. And that makes it also a bit of a target if you look at the way that software is being produced from beginning to end. So that's the topic that I want to talk about. I've done this talk before, there's videos of that if you want to see it. I go into more detail. And the goal of this version of the talk would be more practical and showing you some bits and pieces of what we can solve within the .NET space to do a better job. Also need to emphasize that it's a work in progress for a lot of companies. Also, the big companies that have stepped up and said like, hey, we need to change this, like Google, Microsoft, IBM. They all have the same goal, saying like, hey, this is an essential problem we need to solve. So in order to have some agenda to talk through, first I want to briefly touch what the definition is of software supply chain, or at least the one that I'm going to use during the talk. And then of course we need to focus on how can we secure it. There's like 3 main areas I want to touch, which is like the developer and the way that he or she works with source code. Then, of course, as Robert says, Log4j, third-party libraries, like what can possibly go wrong with those, right? And then we're going to focus more on build and release of software. And then at the end, there will be conclusion and QA. So this content that I'm delivering right now is also stuff that I've talked about 2 weeks ago at NDC London, or no, NDC Oslo. I'm also going to do it at NDC London. So I'll have some repos at the end that have the slides and the demos that I'm showing you. I might cut short the demos a bit for the sake of time, but I will show you around some of the bits and pieces. But it's all in GitHub, and you will have the slides and the notes at the end. So if you look at software development as a whole, right, starting out with monolithic development, which I'm not saying is a bad thing, but it has evolved, right? At some point, service orientation come around. We started doing SOAP as a mix within .NET, right? Highly, let's say, bloated, big messages, XML, serialized, was not a good idea, I think. Then luckily, technology was able to catch up with it, and then we have better protocols, better ways of serializing data. And then we're doing serverless and cloud native stuff, right? So it's more smaller chunks of software that needs to be deployed across a cloud infrastructure, which luckily for us also results in more software and more, let's say, more moving parts that we need to be aware of in our software supply chain. If we then look at supply chain as a whole, like how would I define it? The analogy I always use is car manufacturing. Right? Because at some point in a factory, there's a lump of steel where it starts out, and then at the end of that factory line, there should be a car ready to be delivered to the customer that ordered it, right? But throughout the steps, each step will add value to that car, which eventually turns into the end product, right? So that lump of steel turns into a chassis and everything gets added. In a German car manufacturer, will have at least like 10,000 parts being put on a car. And those 10,000 parts are like originating from 2,700 different suppliers that have all added stuff to this car, right? So 2,700 different other companies build stuff, but eventually ends up in the car. And that's a supply chain right from beginning to the end. If we then look at what we state for software, we can probably have similar analogies, like in such a way, like we start out with source. At some point, the developer works with source. Code is being built, right? The developer and the build server have interactions with third-party libraries like NuGet, NPM, or maybe even Docker images that are being composed during out the process, right? Assuming that everybody does some Q&A before delivering software to production, doing testing, doing some maybe some stress testing, security testing. And then at the end, there's a deliverable, which might be an artifact that can be a library or a Docker image that will be pushed to, let's say, for example, a Kubernetes cluster. So this is a hypothetical software supply chain that has software like that starts out as source, ends up at binaries that are like deployed somewhere, right? So this is the main stretch I want to talk about from conceptual view. There are different areas, and let's say this is just a .NET supply chain of an app that gets deployed. What could possibly go wrong? And then the first example I always give is, of course, the stuff that happens with SolarWinds and with their Sunspot, which eventually turned out that one of their build servers, which run on TeamCity, I believe, I think they had VMs running there, was compromised, and each build resulted in additional things being added to the package, the product that they deliver across the world. Keep in mind, SolarWinds is, as far as I'm aware, like monitoring software, right? And they get deployed across organizations and big organizations. So from attackers' perspective, it makes a lot of sense to focus on that type of things, right? Because if you, let's say an infrastructure is locked down, then I think an attacker would move to layer 7, to the application layer, on doing the thing he or she wants to achieve, right? So that's the trend we see with these types of attacks. And this was a build server that was compromised, and I believe they just dropped some bogus code in it first to see how it goes, and then they saw that it was deployed with the release, or it was part of the release. Motivations, who's behind it, that's all hypothetically speaking. There's a lot of stuff being written by CrowdStrike. Has got this good blog post. All the links that I'm referring to are all in the slide notes, so don't worry about them. And Microsoft also has a good blog post on some of the network infrastructure messaging and what happened with this attack. So it's been pretty big. I also want to emphasize that we're gonna go back to SolarWinds at the end, at the last part of the presentation, because they solved this problem in a really good way, and that's also the direction we're going to head. One also side note I want to give is that I think the supply chain problem as a whole is not something we can easily solve with tools, but we need to do a better job as a whole. And that's exactly what we're going to focus on with the rest of the talk. So if you look at other supply chain attacks, then something that probably comes to mind is something that happened to Cassaya, which is a managed service provider that was used by a lot of companies to like take care of their IT infrastructure. Because if you're doing logistics, then you might not like have any like business in IT. You need to use it, right? Because eventually every company becomes a software company. But this is a big thing. This is a blog post done by Sonatype, and there's some question about like, hey, is this really a software supply chain attack, or is it more like a supply chain attack? But I think the trend you see over here is this is also targeting infrastructure software, and it has a big foothold, and that was probably the reason. I believe this was just an ordinary SQL injection in the product that was Cassaya, of one of the Cassaya products, and that then got deployed across the different versions that were used by the managed service provider. So it's a SaaS that everybody consumes. So that's it. So SQL injection turned into ransomware and turning into data getting encrypted, and they wanted to have money in order to get the data back, right? So question, is this a software supply chain attack? I would say no, but as a whole, it definitely is a supply chain attack, because something bad happened and a lot of people were involved, of course, with this. One picture I always need to share, you probably have seen it also with some of the Log4j posts on the internet over the last couple of days, is of course these cartoons, we all know them. And this one is just like illustrative for the problem as a whole. If we look at, and this is only referring to modern digital infrastructure, but you can replace it with every piece of IT or software architecture, whatever you want. But somewhere underneath there is that project that's some random person in Nebraska is thanklessly maintaining since 2003, right? And if you look at Log4j, I think it was like, it's run by 3 people, I believe. And yeah, there's a lot of trust in doing that. And we can talk about it for a long time, like what the problem is, but I think this is also, if you look at it from risks perspective, this is definitely the illustration you need to be aware of. So let's move on. Let's first talk about the first part of this chain. Let's look into software and interaction with source, right? In order to have source and in order to have access to source, you need to have credentials to access a Git or another source repo. And what happens with credentials? Credentials get stolen. And that's exactly what happened in July 2019 with the Canonical account. I think it was just an ordinary credential theft. And what happened is that there was just like some malicious repos created, and there has been no, let's say, clear view on something that would have happened with Ubuntu, right? Because Canonical is the group behind the Ubuntu distro. And if you look at my demos later on, the build pipelines that I'm running are all running on Ubuntu. So you can probably imagine if somebody grabs foothold of this, what will happen. How could they have circumvented this? Of course, credentials get stolen, so you should always use multi-factor authentication in the best way possible, right? Or let's say if you're doing your access keys and have access keys for Git, that's also fine, right? Those are bigger, complex things. But username and passwords, if they are compromised, then the additional factor would at least have some risk reduction for that whole story, because you need to have this code in order to use that account. An additional factor that's also valuable, and it's valuable in the whole chain, is something called git commit signing. So what you then do is you create a GPG key pair, which is a public and a private key pair, and with your commits that you push to, in this case, Git, you will sign it with your private key, and then you put the public key inside the repo, and people can see you as being verified for this repo, which of course it's just a green mark, like what's the value of this, but it at least gives you some sense of the origin of where this is committed. So if my credentials were stolen, somebody would have got access to my source repo, then with git commit signing, this verified mark would miss. So that can be an indication that something happened, right? So it can act as an additional factor in this whole story. There's also, of course, possibilities to secure your branches with only allowing signed commits to push through, right? There's a lot of things you can do with this, but I think as a whole, this is a good indicator and it can help you out. And it can also be helpful along the way, which we will see later on. Then let's say if you still have access and if people still interact with source repos, what else can go wrong? And that's the thing that was done by the University of Minnesota, where they did a piece of research, and they, I think what they did is they joined a part of the Linux distribution, I think some parts of the kernel. They became contributors and at some point decided to inject some malicious code as being a contributor to this Linux repo, which of course backfired a bit, and everybody was quite annoyed about this. But keep in mind that somebody can still social engineer their way into doing these kinds of things, right? And if you're a highly motivated person that wants to achieve this, then this is still not you cannot not mark this off. It's still based on people that interact with each other, and that's based on trust, right? So this will still be a risk, and this one is a hard one to solve in such a way that you would always, of course, do a good job if you would do peer reviewing with people on source code before you push something to production. So let's say if there's a piece of critical software in the whole thing that you're creating, then I would definitely have more eyes looking at it before it's get pushed out, right? And that might have circumvented it. But this is a good study to show hey, people want to do bad things, it still happens. So maybe we need to figure out different things about that. What else does a developer need? And that's of course an IDE. And for the sake of time, I'm just going to quickly go over this. But this was a piece of malware that was found by the GitHub security team, and it targeted NetBeans, which is an IDE that you can use to develop Java. And what it did is it dropped a piece of malicious code in each of the builds it was creating. So an IDE can get compromised, right? And that's the thing. And what the goal was of this was pretty sophisticated, targeted against an IDE. Then you could question hey, why not target a build server or something else and not an IDE, right? Those things are a bit hard to understand. Why is this done? But if we don't look at .NET, and myself, I'm a big user of VS Code. But if you look at VS Code, it's based on Electron, right? So the framework used to create it's Electron. And what you see over here is a NPM graph you can create from this website. And if you then look into Electron, you see that there's a total of 82 dependencies on that whole tree of this, right? And this is only the Electron part. So Slack uses this, VS Code uses this. One thing to keep in mind is that in total, there are 110 maintainers that will take care of this 82 dependencies. So there's 110 people touching the code that eventually ends up in your VS Code that everybody is running. That also gives it power, right? It's a tool that I think if I need to figure out something in a different language, then I will just grab VS Code. I will get the extension. I can just do my thing, right? That's the power of that ecosystem. But there's 110 maintainers, and there's even more contributors underneath that touch this code, right? So to a certain degree, there's a risk. And if we don't look at VS Code as a whole, vulnerabilities are found, right? And this is one that was published in the beginning of November. So it's always a good thing to have the IDE updates being pulled in order to reduce the risk, because you're editing the source that you eventually use to build your products with, that you commit to your source repo and so on, right? So this is a part of the supply chain I think everybody needs to be aware of. And similarly, somebody was able to, based on, I think it was the issue system, there was a script that was then triggered based on an issue if you filed that allows somebody to have access to the Git repo, which was I think he stumbled across it. It was not done on purposely, but at some point he saw he was able to do that. So he was able to push code to the VS Code repo right away. And that was the main branch, I believe, that was used. So pretty significant impact if you see this, right? But enough talk about IDEs, about source. So let's now move to the talk of the last couple of weeks, or last 2 weeks with Log4j, but also with other libraries. If we look at the ecosystems as a whole, and this is going to be one rant on Veracode I need to share with you, but we produce a state of software security, and This year we produced an open source edition again, which focuses on open source libraries. And what we have seen within our statistics is that our customers, like they because we are a SaaS, we're able to have these kind of statistics. Almost 80% of the time, libraries get added to an application but never get updated, and that's something that's quite worrisome. You should always keep an eye out, right? Especially what we've seen with Log4j, but all libraries, because libraries will have security problems, right? And it also happens with .NET Core, for example. This is one from October that has related to LDAP, which is, I think it was like plain text credentials being sent over the wire on Linux and Mac OS X, right? That's what the last piece states here. But still, these things occur. You need to update stuff. And the other thing that happens with libraries is that they get compromised for malware, right? And that's exactly what we have seen with the UA parser thing that was inside of NPM. It turned out that there was malware inside of it. It turns out that NPM, the maintainer of this project, only had like simple credentials, or at least those credentials were stolen. And that was the reason why this library that is like downloaded, I think, 1 million times a week, got compromised, right? So aside from security problems that focus on vulnerabilities, there's also that whole malware thing happening with libraries. Microsoft luckily did anticipate a bit on that, saying like, hey, we need to make sure that we force every maintainer to have multi-factor authentication enabled on their account, which makes it harder, right? And also they're analyzing for malware inside the NPM ecosystem, which is a good thing, right? So that's cool. What else could possibly go wrong with the dependencies if we look at a .NET application? That's something that happened with a lot of systems and a lot of like also package systems, but it's a concept called dependency confusion. And this was published in February. I think it was this year, February 2021. So what happens with dependency confusion is that if you grab a package from NuGet, it has an identifier, it has a name. And companies, if you work for a big company, you might have got your own private package repositories with name identifiers inside of it. But what about if you have your private package that you include in your apps, right? Because if you do centralized things, and if you have let's say an application security team that runs the whole thing, then it might make sense to have centralized packages being distributed across the apps, because you know what happens if somebody was able to publish a app with, or a package with the same name in a public repo. What would happen then? Of course, the confusion happens, right? Because do you need to take that external one or the internal one? That's exactly what this person showed in his article. I think he even made some good money out of it with bug bounties, because he was able to take over those big companies you see mentioned here. So if we look at NuGet, what are the abilities that we're able to do in order to limit the packages itself? It would make sense to have more control over a single, let's say, repo that you use, a single private repo, and maybe a system like Azure Artifacts, and I'm sure that probably others are able to do the same, but it can help you managing internal and external upstream packages into a single piece, right? So every app will just consume it from the Azure Artifacts repo that you have published throughout the organization, and it will give you more control. And if you have a company that has packages that have identifiers which you like have also publicly, then you can decide to register that prefix for only your usage, right? So then let's say, for example, .NET, right? That's a prefix that's registered, that not everybody else can like publish packages which starts with that same name, because you might have got that confusion piece. The other thing would be this, maybe be more thorough in like locking down the packages you use for your app, which can be, of course, a quite complex task to do. But if the app is a high risk thing for your organization, then you could consider doing that. So in this slide, there's a note that refers to a document, a really good document that was created by Microsoft, which is called 3 Ways to Mitigate Risks Using Private Package Repositories. And it's exactly written for the dependency confusion problem. So there's some good things. If you want to look into that, then I would encourage you to do that. a small sidestep. So if we look at dependency confusion, like you would always guess like, hey, there's probably more to this. And this was something I ran into when I was creating this slide deck. Turns out that WordPress, that also a lot of businesses, big businesses, small businesses use for their content creation, has similar problems with plugins, right? You can imagine that if you have private plugins that are only like local to you, let's say that you create for your company, and somebody has the ability to publish one that's publicly known, then you can get same situations. And this researcher also made money out of bounties by applying this. So this is pretty cool. And this is published November, right? End of November of this year. So pretty recent. So we looked into Parquet packages that we're consuming. What about third-party libraries? What can we do about this? So this is also a topic that's close to my heart, and I've talked about this, I think, also previously on this group about reducing risk of third-party libraries. I think it's important to know what type of libraries you pull into your application. Be aware of the fact that there is a transitive list of things underneath it, right? So you might think like, hey, I just pull in a single package, but underneath there's a whole tree of transitive ones you get for free. And there might be one that has causing problems, right? So be aware of that. I did a talk in November, which is called Sandboxing.NET Assemblies. And hopefully it's being published on YouTube, I think in the next month or so. But then I focus more on some of those concepts and how you can reduce that risk. So keep an eye out on that. If we then look at initiatives that have been started out, one really good project is something done by the Open Source Security Foundation, or OpenSSF, which is part of the Linux Foundation. And they introduced a concept called security scorecards, which are like security health metrics for open source. And I think that's a pretty powerful thing to do. So if you go to their site, you will find that there are like specific characteristics they look into a project. And based on those aspects that they look at, there's a whole list of things you can dig into. They will give you a figure. And to some degree, this is almost similar like a nutrition thing on side of a piece of, let's say, food you buy in a grocery store, right? You look into it, you're like, hey, this one has got a lot of salt. I might not like take this because that's not good for my blood pressure, right? For example. So scorecards should be able to give you similar insights. And this is an open source project that's being run. And some of the consumers are publishing a lot of good data, and Google started a project called devs.dev. Need to make sure I flip it, which they use security scorecards to show you metrics on the different ecosystems. And I believe when I created this slide, NuGet was not in it yet, but they're working on that one. But if you then look into a package that's in NPM, let's say one of the Electron pieces, you can see the security scorecard on the right on this view. And you see like, hey, the project doesn't enforce branch protection, right? Which can be a risk. They do have a security policy, and they do not do any fuzzing, or at least that's not what they've seen, right? So those are like metrics, and based on that, you can decide for yourself if you want to have this package pulled in or not, right? So a good thing, good metrics have some idea of intent, but also have idea about what's inside, what do the projects do in order to be as secure as possible, right? One other thing, if we look at libraries as a whole and libraries that are created within .NET, so with .NET 5, source generators have become more prevalent. They're being used a lot more. So they're based on Rosalyn, right? On the analyzers you can create. Source generators allow you to generate code at compile time. But third-party libraries can also contain source generators. So this is a blog post that's been written by one of my colleagues, Matthias, who digs into a malicious example like, hey, what can you achieve with source generators that are being put into a library with malicious intent? And he's got like a nice thing like, hey, this might be the next supply chain attack, because source generators can just be put in, and at build time, they will be recognized and being pulled in. So if you're not aware of those being inside the package, which might be there because it's needed to create some code, right? Because source generators move us away from the need of reflection, and that's good because that's performance. It also gives us more insight, like from analysis perspective, I can see a lot more. There's less stuff I need to write down, like, hey, at runtime this happens, right? If we look at those things from static analysis perspective. So it has benefits, but it also has a couple of downsides, which he illustrates in this blog post. So if you look at source generators as a whole, what could you do? If you're really worried about this, then you can always consider disabling this at project level. This is just a snippet I copied, which is doing that at CS project level, disabling those analyzers, because but then you might also turn off stuff that you still want to have run, right? You can be more selective and of course enable things. There are some articles on docs.microsoft.com that can help you out doing this, but it's a risk to be aware of if you look at libraries and the ability for source generators just to execute at build time. So we talked about third-party libraries. We talked about what can happen with third-party libraries. Now we're going to move more to builds. And what's really important for builds in supply chain context is build needs to be producible and reproducible, meaning that if you build a piece of source code you get from, let's say, GitHub, you should be able to reproduce the exact same binaries as output, because that will give you the guarantee that the source code you looked at is also the code that ended up in the compiled binary, right? Because otherwise, how could you even verify that that's exactly what's inside? And this is a real tough problem because it's hard to do. There's a lot of moving parts. And if we look at .NET, and if we look at Rosalyn, the compiler stack, right? So Rosalyn started to be deterministic from version 1.1. And there's a list. It says, like, given the same inputs, the compiled output will always be deterministic. So it should be the same. But the inputs is a really big list because it depends on which SDKs are installed, which other things are like installed on your machine itself. There's still a lot of moving parts. And in order for you to reproduce exactly the same, you need to make sure that your build machine is also the same, right? The documents I'm referring to are in GitHub, which are like design documents for Rosalyn that show you the list, and you can see that it's a hard problem. So if we then look at reproducible builds as a whole, reproducibility in .NET, how easy is it? And I'm sure, like, let's move on to some code. Let's do it, because I can say for the sake of time, we can skip it, but let's do this. So what I have here is a console app, and Rosalyn reproducibility, as I've shown before, it has been done with .NET Core from the start, right? So those things are good. We have this console app, a single line app, right? As we have gotten with .NET 6. If we take this project, right? And if we say we're going to copy this project, we're going to say, and we're calling it app2. So if we look into the app2 folder, we see that there's the project file. There's the same thing, right? Are the binaries of these projects exactly the same if we compile them? So this is a script I created, and what it's doing, it will start out doing a .NET build of the two projects, and it will then run a diff, or this is a text diff, but let's first do the compile of the project itself. So let's say .NET build app. Let's say, let's see this, let's maximize this, and let's say .NET build app2. And now let's just take the diff tool that's inside Mac and then say, okay, we have this binary, we have app.dll, and we have app2.appdll, and then see if they are the same. And then it says, like, hey, these binary files are different, right? And what can be the reason of that? I think if we look into the app size or the DLL size, they're even the same. Let's just skip that. The sizes are exactly the same, but the binaries are different. So if I now run this diff script that I just shown you, which is inside this one, right? So let me run it in this context. It will do the build as you just seen, and then it will run strings, and it will show us the differences. So this is the difference of the strings representation of this DLL. And what we see here is that a lot of it is the same, but there is some bit of difference, right? And that has to do with the debug symbols, the PDB file that's part of the PE header, which is being put in, and that path is different. So in order for us to, so same source, different location on your machine will result in different binaries, because the file size is exactly the same. That was one I would have shown you, but the PDB files path changes, right? There are some tricks that we can just get rid of this. And then we have the same, and then I can reproduce this build, and those are exactly the same by taking out the PDB file. So you should trust me on that, that's happening. But this is, of course, the thing. If you look at it from binary perspective, the only way you can say that the DLLs are the same is looking to its internals, right? And see the implementations that are inside. Let's move back to the slides and let's continue, because what can we do for reproducibility in .NET? There is a package called .NET Reproducible on NuGet, which will help you out doing the right thing. It will set a flag for MS Build, which is called continuous integration. That will take care of some of the paths being resolved into its most canonical form, I believe. And it will also turn on source link, right? And with source link, you're able to point out to source files that are part of Git, right? So people can easily debug from Visual Studio into your source code or VS Code even. And that helps out. That's all integrated with this package. So that's cool. That will help you out. And then if you look into NuGet Package Manager, you will see that your package has been marked as deterministically built. So that's cool. So everybody should be able to check it. The additional part you can do is something called hermetic builds, which is the next step of it, right? So as I said, if you look at build systems, there's a lot of moving parts. It also depends on what's installed on the build machine. Maybe even what order it's installed, that will influence it. And what about if the build server itself decides to get a package from a repo at build time, right? You might not even want to do that. So hermetic builds can be done if you include a .NET reproducible isolated NuGet package that will also lock down, for example, where NuGet packages are being resolved, which paths are being used in order to do that. I think that will be the next step. It's still not fully hermetically closed, right, from the outside world, because you would just like to have everything on a build server and no interaction needed from the external world. All inputs go in, package get built, and it's been pushed out. There are even projects that focus on doing reproducible build instances, right, by providing you a build server for that matter. So there's still some stuff to gain in this area, but these packages help you out moving forward. So we talked about reproducible builds, we talked about third-party libraries, we talked about source. Let's now talk about signing artifacts, and also the fact that I think this is important to do. So another, I think it's the Linux Foundation, Open Source Foundation project has been started, or the Cloud Native Foundation even, started a project called SixStore. SixStore is, as the site states over here, a new standard for signing and verifying protecting software. So what SixStore wants to achieve is they want to become the Let's Encrypt, which you probably are all aware of software signing. Because if you look at a certificate that you can use to do code signing, it's really hard to get one. I think you need to manually request it, and it needs to be ID needs to be verified, and then you get a certificate that you can use for, let's say, 3 years to sign your packages with. But SixStore has taken the other approach, and they want to be doing similar things as Let's Script, but then for software signing. So that's really cool. If you look into their website, you will find that there's a whole architecture like how it works. But the power lies behind the fact that they have a root CA that will hand you a certificate that you can use to sign your package with. There's a transparency log that others can check out, saying like, hey, this package has been built by Niels and has been signed by Niels. You can check the transparency log if that's exactly true. So that's pretty cool stuff. And there's also an implementation called cosign, and cosign allows you to sign container images like Docker images. And the funny fact is that it can all be done automatically. So let's say if you're like building a Docker image that eventually is the artifact you're delivering out, that you're like maybe releasing or putting into a Kubernetes cluster to get executed with cosign, you can do even keyless signing based on OpenID Connect. And now it gets really, really cool. So what you then do is you can start out, and you can also do it locally. You start out a cosign for a specific Docker images that you created. Then the OpenID Connect comes in. It will ask you to sign in for, let's say, Microsoft or Google. And then you will get there. You will provide the identity that will give a cosign the identifier, because they have a trust with Microsoft. You will get like, hey, this is Niels Tanis, and he wants to sign something, and I vouched for it because he logged into our authentication system. And that's being put into the signing certificate, and that will then be pushed back to me to sign my container with. The funny fact is those container images get signed with a certificate who has a lifespan of, I think it's like 15 or 30 minutes. It's really short. It's enough time for you to sign. You do not retain the keys. And after it's signed, then the certificate will expire after that, let's say 15 minutes. But then the signature is still intact, right? The timestamp matches because it's being signed at the moment when the certificate was valid. People can look up the transparency logs and see the certificates in. So there's a whole chain of things, right? So it doesn't guarantee that there's no crap inside that image, but it gives you some authenticity checks that you can do. And the funny fact is that GitHub Actions have released OpenID Connect support from the GitHub Actions pipeline, and now it gets really cool. So what I got, and as I said, for the sake of time, I'm just going to skip it a bit, but there's an end at the end. There's that GitHub repo I mentioned. There's one web build that I have, and it also does this GitHub Action OpenID Connect to cosign. It builds a Docker image and then it will sign it. And the cool thing is that, as I said, you have the guarantee that that build server with that identity started out that build of that Docker and then signed it, right? So that's a chain that you've covered, which I think is really cool. And you get it for free, so why not use it, right? So definitely something to look into, because that takes part, at least that focuses on building the artifact and releasing it and signing it, right? To have some authenticity. Now we're going to move back a bit to the automotive industry and see what are the other problems, right? Because some of the supply chain things we talked about before this are all pinpointing things you can probably fix by taking action at that moment. But how can we guarantee that the car is being, let's say, built with parts that we can trust, right? So I think everybody has been in a situation where you get like an email or a call even from the dealership saying like, hey, you need to get your car back to the garage because one part, maybe the seat belt or the brakes or something else, we know that there are problems with a specific series that we produced. So you need to do a callback of those cars, get that fixed, so everybody is safe on the road, right? And that's exactly what the automotive industry does really well, I think. So hypothetically, they're still used to create disc brakes, and then those disc brakes are being put on different cars. Let's say Renault uses those disc brakes, and at some point, the steel factory recognizes that the batch of steel that they use for specific disc brakes have got some issues with quality, and then recall those cars that are being equipped with those discs that are produced from that steel, right? So there's a whole ledger of stuff. And for software, we need to have similar things. We need to know which source has been used in order to build that product that gets deployed, right? So in comes something which they call software bill of materials, which should be an industry standard of describing software. And this is something I think you can even find on the NTIA website. It should at least describe like who produced it. Is it being unaltered, right? What's the licensing? How is it created? What's the materials being used? It should be that ledger, similarly to that car ledger that they create, being knowing like, hey, the car with this VIN has got all these parts in this. So the software that I built for this customer is using Log4j, which is a vulnerable version as we've seen right now. And SBOM is not the fix, but can be that ledger that you use in order to determine where you need to take action, right? And that's exactly the goal. So one thing I would encourage everybody to do is start maybe out with something, a lightweight software bill of materials, which is based on Cyclonedx. So Cyclonedx is a project, I think it was based on the OS dependency checker. It allows you to create a software bill of materials of the dependencies, but also of the whole transitive dependency tree that you use inside your software. And if you then take that artifact and keep it, then that's something you can use later on to see like, hey, this vulnerability came out, it affects this library, this version, where is it used, right? If you can have that quickly answered, then you can exactly know where to focus on to fix. So this is a basic, lightweight, as they call it, software bill of materials, but there's also a framework called Intodo. And Intodo is it's been created by, I think it's the University of New York, New Jersey combined, and some others. And what they want to do is they want to have a secure, like a framework that allows you to secure the integrity of software supply chains. And the funny fact is that it allows you to identify source and correlate it back to binaries and describe what the supply chain is. And I think Intodo has got a lot of power as a tool. And the demo I gave with my previous version of this talk, there's like a basic example which you can look into that will allow you to understand. But if we look at some of the concepts, is that you are able to define functionaries within your supply chain, which is all GPG keys based, right? So you will have a public-private key pair tied to a project owner, let's say a developer, maybe a release manager, a security person involved. They all will be identified with a public-private key pair. And then what a product owner can do, it can create a layout that describes what happens by who and what are the produced materials and byproducts, right? So a build is done, it's based on software, which is being built on source that's being checked in by the developer and git commit signed by the developer. I'm doing a security scan that will have a byproduct that's called the security report that I want to sign off also. And then all those steps are being put into link metadata files. And if you then look at one of the demos, you will see that there's like separate files being created for each of the steps. And then you can use those link files and then ask Intodo to verify the supply chain. So let's say at some point the build server mangled with some of the source files that are being built, then that hash, because it stores also hashes of files, doesn't match the hashes that were being put in by the developer that committed it or that tagged that branch to be released, right? So this is pretty granular. It gives you control over each of the steps. It also is pretty labor intensive to do because the demo that I gave, it's like you need to grab files from literally everywhere in order to verify it. And is this the way out of supply chain problems? I think this is a good step forward, but I do think that this is too complex and maybe we should focus on a better solution for this, but this is definitely heading into the right direction. So as I said, I'm just gonna quickly jump over the demo because I want to briefly talk about that better way of doing software supply chain SBOMs and get back to the company what we started out this presentation with, which is SolarWinds. So at the software, I think it was the software supply chain security supply chain con, supply chain security con, that's what it's called. It was held together with KubeCon in October of this year, I believe. SolarWinds had a presentation which they focused on a project called Project Trebuchet. And what they do is they have looked into the way that they were hacked based on their build servers being compromised. And what they then do is they started to develop a system which they said that they're going to publish it publicly. I haven't seen it being published yet, but it's based on Tecton Pipeline. So Tecton Pipeline is a cloud native CI/CD system that will run on Kubernetes and that will give you more control. So one thing that SolarWinds didn't want to do is like hand over their builds again to, let's say, GitHub Actions or Azure DevOps, or maybe even GitLab for that matter. They wanted to keep it close to themselves. And Tecton has got a really cool concept because it allows you to do YAML similarly as actions. It allows you to describe a build file. But there's also a thing called Tecton Change. And what Tecton Change does, it can do the in total type of attestations on build steps that is being done. So check out source, build step. It has grabbed these files. These are the signatures. Okay, next step is .NET Restore. Okay, it has get these packages from a repo, and these are the signatures, right? So each of those steps are being put into a document database and then being used. And before you can release, then you can do some intelligent queries on those data stored elements, saying like, hey, I want to release this version. Did the security checks meet up all my expectations? Is there anything wrong with maybe a source change that I didn't expect for that matter, right? So there are some steps you can do. And then eventually they release, I think, Docker image and binaries to S3. But this is cool because what they've taken is less of labor, as I've talked about with in total. Each step needs to be done. If you look into that source repo I'm going to share at the end, you will see that the in total calls are part of the GitHub action steps, and it's not getting any easier to read. This will just store the data. And also there's like no real definition of a supply chain needed, right? Because if you need to describe like, hey, source goes from A to B and should be unaltered, maybe you should just store all the data and all the artifacts and inputs and outputs and do queries on that. And that's exactly what they want to achieve with this. But I think the cool thing about this system, how can you check this, that nothing happened with the supply chain? So this is the one that's being publicly used by the developers. They have got a second instance running next to it, which is more controlled. And they call it their validation cluster, which is only accessible by security people or a small group of people. And then they will redo that same build, and they would expect the same output. They would expect the same artifacts being produced. And I think this is a real cool concept. So at the end, they can do those cross checks and say like, hey, I built this based on the standard cluster that was being triggered by the release that we want to do. And then that validation cluster can sign off and say like, hey, yes, this matches, this is exactly what I want to achieve. I think this is cool. And this solves that build server being compromised problem because there is that second instance running. And also because they've taken some countermeasures of controlling more what's happening. I think this is a real cool concept, but I like the fact that this is still also using SixStore underneath the hood for signing things. It uses in total format attestations also. But the nice thing is that Tecton just leverages it and using it. There's no need for you to squeeze it in. So that's really cool. Another project is run by IBM. And it's based on Openshift, and Openshift is also based on Tecton. And what they do is they have a real cool concept where they have zero trust approach on securing a supply chain, which is like deploying microservices based on containers. And if you look into the details, and I'm going to share a picture that has a lot of detail in it, so don't try to understand it fully, but there's the same thing you saw with SolarWinds. They have a build pipeline that will do all the steps, that will produce artifacts, and that will also have a data being registered, like this is the SBOM data. And then they have the admission controller on the bottom of the screen that will decide if they want to sign off for this image that is being built, because it runs through all the rubber stamping that's been done and say like, hey, this is good. We can deploy this. So this is really cool. So this is something you can also find if you look into IBM Openshift. The Red Hat team, I believe, created this, and the blog post link is inside that slide note. When I first started out with this presentation, there was like in total, and there was like Graphius and Credus being created by Google. And the funny thing is that Graphius already was something solving a problem I was seeing with in total, because it allows you to store data, component metadata of an SBOM of a build step that's being done. It's being put inside a database. And then Credus is their like admission controller or like policy checker that you can do in order to check before you deploy. And that's really cool. So they were already like ahead of the curve from that perspective. Aside from the fact that when they published this, there was like no real how can you do the attestations? How can you produce the artifacts and the signing artifacts? And that's, of course, now being covered by the things you saw in the slide before with SixStore, with Intodo, and so on. So there's a lot of movement done, and I think this is important, that this will give you the information you need in order to take better decisions in your supply chain, right? It's not going to safeguard you from any attacks, but it at least gives you the advantage of knowing what happened when. Is that a similar thing that we can do with Azure? And the answer is yes. So the admission controller you saw with IBM Openshift is based on OpenAgent, and Azure Pipelines also, it has the ability to do OpenAgent checks before it deploys stuff to a cluster. And it has the same format, so I can see that there is potential of this being used for similar checks within the ecosystem. But then still, it needs to be more integrated in, let's say, Azure Pipeline builds, the builds part or the GitHub Actions part, in order to have data that you can use to leverage it. The artifacts policies they have shown in this documentation right now only checks for like, hey, this Docker image has this port open, this port should be closed, and it should be like this base image, for example. Those are attestations you can also check, but it doesn't give you that much power. So this is a lot of information and a lot of things. And then when I started out, like with this presentation, there was also the introduction of this version of this presentation. There was also the introduction of something called Google SLSA, or Google Supply Chain Levels for Software Artifacts. That's how the acronym is being called, or Salsa. And what Salsa describes is that I've shown you some risks. I've shown you some things that might go wrong and stuff you can do about this. And Salsa can be a maturity model for you to go through. It has different levels of Salsa, how they call it. And each level will increment itself and will give you better control over your supply chain by making sure that you use scripted builds, that you do the SBOM things at certain points, that you have reproducible builds. It's all been defined inside of Google SLSA, and there's some good documentation around this. If you look into the risk model that they find, you'll probably recognize my build picture I showed you at the beginning, the supply chain as a whole. I was a bit in doubt, like, hey, should I start out with this? But I don't want this to be an SLSA presentation. But I think SLSA gives you a good starting point if you're interested in doing a better job in this, and then go through what's inside your software. So with that said, I'm just gonna wrap up because we're already at the hour mark. I'm getting close to hit bed. If you look at software supply chains as a whole, I think the conclusion should be supply chain hacks happen, and it's not of how, but it's more a matter of when. I think if you look at build systems, or like the way that systems are being developed, make sure you're aware of the fact that your own supply chain also relies on supply chain of libraries that you're consuming. It's a chain, right? And if that one gets compromised, then technically speaking, your own software is compromised. So know what you're pulling into your project, like know what you're using. I'm working for a security company, so I can only state like, hey, make sure you integrate security to your development lifecycle. And please look into how you can maybe start leveraging concepts like SBOMs with maybe Cyclone, maybe a bit of Intodo, or if you're like on Tekton already, then Tekton change should be the thing that's next on your list, and see how SLSA can fit into your process, but taking it to the next direction, right? And then, as I said, this is still a thing that's being done right now, and it's moving. That's good. There's also a lot of gaps, and we also want to make it usable, right? I think Intodo might be a bit too complex, and if you introduce too much complexity, then that won't help you out from security perspective. But as I said, these are all good steps to the right direction. So the two repos you see over here are on GitHub. The first one contains the reproducible thing I've shown you, and also some of the Intodo bits. And the one that's beneath, which is the web app that has the build pipeline definitions, the one that does the Intodo build steps on a commit. And there's another one that will produce the Docker image if you do a tag on that. But you can see the build runs inside of it, and you can check it out yourself. Yeah, if there's like more questions, or if you want to talk bit more about this, then feel free to drop me a message on either Twitter or drop me an email. And I think that's about it, what I have for today. And of course, I'm still open for questions right now. So I know that this is a lot of information, but yeah, I think it's good to think about this and to make sure that you're like anticipating any problems that you might run into. So yeah, are there any questions, or is anybody silent and getting ready for dinner because it's close to 6 p.m. It's already past 6 p.m. right? So I'm sorry, let me put that one back.